Good day all, welcome to this new video in which we're going to have a practical look at using time. Now we did have a look previously at functions that use time. For example, the at now or the is equal to now function, the is equal to time function, and the is equal to date function. There are more functions that will give you the value of time, but those ones we did have a look in previous videos. To recap quickly, the is equal to now function will give us the date and time of now, which means the time at which we put in the function. I have then formatted it to a physical time when it gets put down. So let's go down here somewhere and go is equal to now. We see that I press enter there. We see that the function now gives us the date and the time. We can format that into only the date, and in any format we like, or only the time. And that's what I've done here at the top. It is now formatted only as the time. The number behind it, and it suggests that it is a number because it's on the right of the cell. If it was a text or a character field, it will be on the left of the field. So if I just put a name down, a character field will appear on the left, like in just an H. Sorry, I said just an H. Or I can just put a 3, and that will put it on the right. So you can the position of the value entered will suggest what it is. Now that is not always true, because any number, like what this suggests, because it's on the right, it suggests a number, but I can format it, I can align it to the left. Now it suggests a text. So what you see is not always what is suggested. We must look at you can see this, it is now to the right, and it has been aligned to the right. If I align it to the center, it is now aligned to the center. So you can see that a value is aligned by what is highlighted in the format bar here. Normally when I put a 3, it is not. So this is unformatted, unaligned, and it is a 3, and therefore it suggests that it is a number. If I put that same 3 over here, it is on the right, and sorry, on the left, and therefore it suggests it is a text, which it is because I put an apostrophe in front of the 3. So it is not always what you see is what you get. I can delete those things, and I can go back to, I can format, remember, I can format by copying any place with no formatting, paste it over the format that you want, and now it is not formatted at all. And please note that the equals to now gives us a number, a integer and a fractional part of a number. The integer being the number of days since the 1st of January 1900. So there have been 44,110 days since the 1st of January 1900. The fractional part, which is 0.40179, is the time of the current day. So once this day is finished at 12 o'clock tonight, at the split second where the days change, this will be 0.99999 not ending, and the split second that it clicks over, it will be 1, and the integer part will be 44,111, and the fractional part will be 0,0000, and then it will start again. Now in the day, at 12 o'clock, when the time is exactly 0, the fractional part is 0. At 12 o'clock in the afternoon, we have spent half the day. So exactly at that time, the part of the day, the time will be 0,5. If I take 6 hours prior to that, I'm at a quarter of the day, and the fractional part, the time, will be 0,25. If I take 6 hours over the 12, I'll be 0,75. And 6 hours after that, at the split second where we click over to the next day, the number will be 0,99999, tick it will be 1, and it will go over to the next day. And that is how the time and the date work. So we have created a machine called a tensometer, in which we calculate, or we put stress on a piece of material, and on the one side we put tension on it to see at what stress level the material breaks, and on the other side of the machine we can put stress, or we can put pressure on the material, and see how long it takes. So you put it to a certain, and in this case 115 kilograms, 115.89 kilograms, and you leave it, and you see how long it takes to get to a certain relaxation. And this test, so we put a stress of 115.89 kilograms on the material, and it took 150 seconds to relax to 110.305 kilograms. So the difference in 150 seconds was 5.585 kilograms over the 2.5 minutes. Now, if you do nothing else, so I started the test at 7:36:55 in the morning. The test was finished at 7:39:25 seconds, which is 2.5 minutes later. So the beginning and the end, you subtracted 2, it's at 2.5. It took exactly 150 seconds to do this test. You could do completely different tests. You can take a piece of material, compress it, and leave it for 24 hours and see what happens in those 24 hours. But then you won't do it every second. You would maybe do it every 5 minutes. Take a reading every 5 minutes, and so 12 times in an hour times 24, you would get 130 something, 132 or whatever it is, readings every 5 minutes over 24 hours. And you could then do the same thing, how the difference between the beginning stress and the end stress over 24 hours, and see what numbers you get. But I'm talking about the time. So the time is a number, and that number is the part of the day that time was taken. Now that is the important thing. You must always remember it is the part of the day. Now how do we calculate that, or how do we look at that? One day is 24 hours, so we take 1, which is the day, divided by 24 hours, which gives us 0.041666 recurring, which is an hour in 24. If I take that 1 hour and I divide it by 60, I get 0.0006944 recurring, which represents 1 hour of the day. And if I take that hour and I divide it by another 60, I get 0.000, so 4 noughts, 11574 seconds. Now, there are 3600 times 24 seconds in a day. So if I multiply, if I take, and I do that, and I say 24 times 60 times 60 times this number, I should be getting 1, because I've related it all back to one day. And all these numbers that we look at are therefore parts of the day. So at 7.3655 is parts of the day. We are 0.317 part of the day into the day. Now I've shown that here. At the beginning of the day, at 12 o'clock, we are exactly at half the day. So 0.31, which is a little bit before 0.37. So we're in between 6 and 9. If I want to do it exactly, I can go to 7, and the 7 part is 0.291. And because we are half an hour later, I could take, and I've done the calculation here already, we're at 36 and 55 seconds. And here we are at 15. Oops, sorry, I took the wrong, we are at, not 7, sorry. Let's make this. Sorry, I took the wrong mistake. That number. So now we are at 7:36:55, which is exactly the time 7:36 and 55. Now if I format that into a normal number with a few decimal places, I would get exactly that value. But it is the part of the day. That is the message here, is that it does not give us it's not the time, it's not, sorry, it's exactly the time, but it's not the fraction, as I mentioned, is the part of the day. It's not the actual time. So coming back to, the test, the 2.5 minutes gives us, relates to 0.001736, which is not the time. It is part of the day. So 2.3, if I would take 2 minutes past 12, so if I take the naught as 12 o'clock, and I take the minutes as 2 minutes, and I take, where were we? At 30 seconds. Take 30 seconds. The number is now exactly the 2.5 minutes that it represents, but it's not the time. The point I'm making is that it is a part of the day. Now in this case I took 12 o'clock, 2 minutes and 30 seconds, which gave us exactly the time. It was 2 minutes and 30 seconds after 12 o'clock. But when we did the calculation, it gave us 2.5 minutes. So be careful not to see those numbers as time, but as part of the day. And I could then say how many seconds go into that time. So I could do in the calculation, say, is equal to that divided by the number of seconds, and I get to exactly 150, which is the number of seconds it took to get from 7:36:55 to 7:39:25. Now I know that it gets quite complex, and not complex as in difficult, but confusing, I would say, in times. But the thing to remember is it is always a part of the day. So working with time, the easiest way is to leave it in the format that it comes, which is the format of time, remembering that it is a number and working with it. So subtracting those two times, we get to 2.3 minutes, which is, again, like in all things in life, and it sounds simple to remember, part of the day. It is not the time 2.5 minutes after 12, but 2.5 minutes from beginning to end. This is what I wanted to show, and thank you very much. See you in the next video. Goodbye.